Hi, Year 9. This is the second part of the squares investigation that we're doing this week. I'm going to start off by putting on the screen the answers to what you've been doing over the past couple of days. Okay, so this here is the list of all the areas that you can get from 1 to 50 using tilted squares. Okay, so I'll remind you as to what we mean by this. So if I pick a couple, so a 4, this one here, I can make an area of 4 by drawing a square that's got a tilt of 0, 2. Okay, now what that would mean is that it's just an upright square that's not really tilted, but it's 2 by 2. Okay, and that would have an area of 4, wouldn't it? Okay, so that would be that example there. Let's pick a different example. This one, 13. Okay, so this one, I can make an area of 13 by drawing a square with a tilt of 2 by 3. Okay, so what that would mean is that if I draw a triangle like this, that's 2 by 3, then the square that goes on top of that, this one, which isn't the greatest, but there we go, that square there would have an area of 13. Okay, and if you remember those triangles, there's 4 of them that go all the way around, so you've got another 3 by 2 there, you've got another 3 by 2 there, and another 3 by 2 there. Okay, so just to recap from last time, so that's the square, 2 by 3 is the tilt, all right? And then the rest are all the other possibilities that you can have. Okay, and what we're doing today is we're trying to find a link between the area that you get and the tilt numbers, okay? If you look carefully at the numbers that we've got, you might, if you stumble upon it, you might discover what this link is, but if you can't figure it out just yet, we'll have a look at some examples with some pictures and do it a bit better than that. So basically, is there a link between the numbers over here and the area that you get? Okay, is there a shortcut that takes these numbers and produces this one? Okay, before I move on with the video, you might want to pause and just have a little think about it to get and see if your rule works for all of these examples, and then we can test it out in a little bit. Okay, so pause the video and I'll come back to you in a few seconds. Okay, so let's move on. In order to suss out what's going on with these numbers, I want you to pick an example that doesn't have a 0 in it. Okay, so you're not allowed to pick a square number, basically. So not this one, that's got a 0 in it, but maybe pick one like this, where both the numbers here don't have 0 in. Okay, so it's definitely a tilted square. All right, now I'm going to do a couple of examples, but I'd like you to have a go at a couple of your own, just to test it out and see that it works and that you can do it yourself. All right, so we're going to go back to the diagram that we've had in the past. I'm going to move to the next slide. So I'm going to pick an example, and the example I'm going to pick is this one that has an area of 25 when the tilt is 3 by 4. Okay, so if you go back to the table very quickly, so basically I'm doing this top one up here, area 25, tilt is 3 by 4. Okay, that's what I'm going to do. Okay, let's go back to the picture. So there. Okay, there's the tilt. And we're going to put the rest of the numbers on and take a look at this picture in a bit more detail. So without even looking at the dots, can we work out what the big square is, how big that is? Well, if I label up more bits around the edge, you've got a 4, and then this edge here is going to be a 3, because it's the same as this edge. Okay, so it looks as if the whole of this edge is a 7, right? And same idea, if I go along here, that's going to be a 4, because it's the same as this edge, and this is going to be a 3. So again, the top edge is going to be 7 as well. All right, so the big square is 3 plus 4, which is 7. Okay, so let's put that on the picture. Okay, so now I've got those. What I'm going to do, I'm going to take a look at this bottom corner down here. Okay, that triangle down there with the smiley face in, I'm going to draw that again, all right, because it's all the numbers that I need to use are around there. So here's the same triangle again, all right, with the same smiley face in it, okay, copied over. And we're going to add the tilted square on it as well, okay, and we know that it's 25 because we worked that out before. But then we're also going to put squares on the other edges of this triangle, okay? I've got a big tilted square on the long edge, okay, over on this edge, but if we put squares on the other side, and this side down here as well, it will help us out. So here's another square. Okay, attach it to that left-hand side. Now that square is 4 by 4, isn't it? Because that edge there is a 4. So if I square it, you get 16. And on the bottom edge, that's going to be a 3 by 3 square because it's attached to that 3 by 3 down there. So that's going to be 9. Okay, so now we've got these 3 squares. I want you to think about what's the link between the 3 numbers. Okay, how do we get from what's the link between these 3 numbers basically? Okay, so what links these 3? I'll give you a few seconds, but I'm going to do one more, and then hopefully it'll be clear after I've done the second example as well. Okay, make sure you write down what you've noticed as well, and then we're going to prove it as well. Okay, second example. Okay, here's my second tilted square. This time I'm putting a tilt on of 2 by 6, and when you work that out, you get an area of 40. Okay, maybe that's one that you've done before. Right, so now how big's the big square this time? Well, it's 6 and 2 extra up the side there, so it's going to be 8, and if I go along there, that's going to be 6 and 2, so 8 as well. So there's the big square. So you're going to add these 2 numbers again, 6 and 2. Then we're going to draw this triangle again. So copy that triangle into a space. Put the tilted square on the tilted edge, okay, the long side. The area is 40. And then add the other squares. So if I put that square on that side over there, that's on the 6 edge. So I'm going to make a 6 by 6, which is 36. And on the bottom shorter edge, that's going to be 2 by 2, which is 4. Right, okay, hopefully now with these easier numbers, you can see the link. Okay, how do we link these 3 areas together? Okay, take a moment, write it down as a sentence. Okay, and hopefully you've spotted that the 2 small squares always add up to the big square. Okay, so that's one thing that you can write down. So for this triangle at least, and the one before it, 36 plus 4 equals 40. Okay, so the 3 areas, the 2 small ones add up to the big one. Okay, right, I want you to try this again with your own example. Okay, you draw yourself a tilted square. Okay, it doesn't have to be on dotted grid, just draw it as a little sketch. Put your big square around it, add the numbers, and see if your 3 areas add up to the big one. Okay, or the 2 smaller ones add up to the big one. Okay, just check it works for your own example. Okay, right, now we've done that, we're going to prove that this works, okay? And to prove that it works, or every time, we're going to need to use some algebra, okay? So this is the hardest part, but we're going to do the same thing again, just using letters rather than actual numbers this time, okay? And see what happens. So I'm going to move it to the next slide. We're going to do this one more time, but using algebra, okay? And this is on your worksheet as well. You can fill in the gaps on your worksheet as I go through it, okay? So that we're on this current page here. Right, so any old square then, any square you like, any tilted square, but this time the tilt is going to have algebra in, okay? We're going to use A and B for the 2 numbers for your tilt, okay? We're also going to add this third side, all right? This side's going to be important as well. This long edge on the diagonal, we're going to call it C, all right? So now, using those 3 letters, we can fill in the other details about this diagram. So first of all, the tilted square, because it's C, and it's C on the other edge as well, right? It's a square. It must be C by C, which makes C squared, okay? So the area of the tilted square we know is going to be C squared. So I can write that in first of all. Right, then the long edge of the square, these edges, we know what the rule is to work this number out. It's the sum of the A and the B numbers. Okay, it's the sum of the tilt numbers. So I can write in here A plus B, because it's those 2 numbers added together. All right, so that's our picture filled in using algebra. Now I'm going to do the same as before. I'm going to draw this triangle in again. I'm going to work some things out. Okay, so here's the sum that you've been doing before. We know that the areas are linked using this little equation in here, right? The tilted square is the big square minus the 4 little triangles around the edge. Okay, that's what you've been doing, but you've been doing it using numbers. We're going to do it once more time using algebra. So let's fill in what we know about these things. The tilted square, what's the area? Well, we've worked that out a minute ago. That was C squared. Okay, you can fill that in the box. The big square, Well, the big square is a plus b on this edge and another a plus b on this edge. So when I times these two things together, it's going to look like this, a plus b squared, because you're multiplying it by itself. Then it's minus 4, because there's 4 triangles. Now, how do we get the area of the little triangle? Well, the formula is a half base height, and the base and the height that I'm using are these numbers a and b. Okay, so these 3 pieces represent these 3 shapes. Okay, all we've got to do now is tidy up a little bit, and hopefully we'll see something that's kind of important and interesting. So, firstly, I want to take this bit here, this little bit of algebra. I can write it in a different way. Okay, I can take out these brackets and write it in a way that's going to tidy up with some other things over here. So a plus b squared. I want to times that out using a grid. All right. So here's the outside of my timesing grid. This top row represents the one of the a plus b's. Okay, that's an a plus b, and then this is another a plus b, and I'm going to times them together. Oh, that was terrible. Let me try that again. That's another a plus b there. Okay, so when I times these things out, I need to fill in this little grid with things timesing together. In the first box, it's a times a, and that's going to make an a squared. Okay. In this box, this is an a times by a b, and that's going to make an ab. The bottom left box, that's another a times this b, that's going to make ab as well. And then finally, in the bottom corner, this is where you've got a b times by a b, and that makes b squared. Okay, so we're going to replace this square bracket here with these 4 little mini pieces, and then we're also going to tidy up this triangle bit over here as well, because what we can do is I can look at the 2 numbers and tidy it up. Look, because look, what's 4 times a half? Well, 4 lots of a half makes 2. Okay, so I can replace the 4 times a half with just a 2, and that will make it a bit tidier. So let's take all of that over to one side and we'll write it out again. So one more time, c squared is the left side. Then this first term, we've written it out as 4 little smaller terms. We've got a squared, and then ab, and ab, and b squared. That's these 4 down there. Minus, and then rather than 4 times a half, I'm going to replace it with a 2. So it's just 2ab. All right. Now I can do some cancelling out. Things are going to tidy up quite nicely. So looking at the 2 terms in the middle here, now these are like terms. This is the same thing added up twice. So I can replace it with just 2 lots of AB. So a squared stays the same. AB plus AB makes 2 lots of AB. B squared stays as B squared. But then at the end we subtract 2 lots of AB, like that. Okay. So now you'll notice you've got 2 terms that are cancelling out here. These 2 ABs are positive and negative. They cancel out, so I can get rid of those. And then finally, we've got the simplest version of this equation, which looks like that. Okay, so fill in all the gaps. This is the important bit we're trying to get towards, and that is probably one of the most famous theorems that you learn at school. If you ask your parents, they'll tell you the name as well. And if you know yourself, and you can look it up, it's called Pythagoras Theorem. Okay, so what it tells you is what we discovered on the previous slide, in that the area of this square here is the area of the square down there plus the area of the square over there. Okay, the 3 squares, or the 2 small squares add up to the big square. Okay, so that's important. You need to write that down. Right, so that's going to be really useful. That means we've got a shortcut now where we can work out these square areas quicker than doing the entire thing all over again. All right, or if I know these tilt numbers, that's all I need to work out the square size. Okay, so now I'm going to show you how to use this theorem. All right, so here it is again. If you've got your triangle down here, it's A, B, and C. C is the long side. Then this is the theorem that we're using. Okay, C squared is A squared plus B squared. C squared is the area of the tilted square, and then these 2 are the squares that we put on the other sides, right? The 2 smaller squares. Okay, so let's do another example using this theorem. So here's the tilted square. Here's the tilt. It's 2 by 1. Okay. Now to get the area, rather than do the whole sum again, all I need to do is square these 2 numbers and add them together. So the tilt is 1 by 2. If you do 1 squared and 2 squared, add those together, that's 1 plus 4, and that makes 5, which was the area that we had before when we did this the first time. Okay, so that's the quick way. You square the numbers, add them together, and that's the area. Okay, so let's see if we can find some other examples. Can we make a 61 square? Can we make an area of 61? Well, if we list out some square numbers, you should be able to find 2 of them that add together to make your big one. So let's list out some square numbers first of all. 1, 4, 9, 16, 25, 36, 49, 8 times 8 is 64, and then 81, and then 100. Okay, so these are some square numbers. It might be quite useful for you to make a list of these so you know what square numbers to use. Can you find 2 of them that add up to 61? Okay, and if you look carefully, you might spot 25, which is 5 squared, and 36, which is 6 squared. So these 2. Okay, that's 5 squared, that's 6 squared. So you can make a 61. So if you draw a tilt of 5 and 6, you can get an area of 61. Okay. Second example, can you make 90? Can you find 2 of these add up to 90? I'll give you a second to have a look at that. Okay, and looking at it, I can spot 1. I can spot 9 added with 81. Okay, that makes 90. And if you add those together, if you write it properly, it's going to be 3 squared. That makes the 9. And 9 squared, that makes the 90. So 90 is possible because it's 3 squared and 9 squared. Okay, so what I want you to do today, this is today's task, for the table on this slide over here, for these numbers 51 to 60, I want you to work out if these are possible areas, right? Can I make a tilted square with that area? And what's the tilt? Okay, I might do the first one for you. So the area 51, which is quite a good one to do actually, area 51, that is not possible. Okay, I can't do it at 51 because there's no sum that adds up to 51. 52 though is possible because it's 4 squared, which is 16. And it's 6 squared, which is 31. If you add them, you get 52. Sorry, 6 squared is 31, isn't it? Let's get that right. Okay, 16 and 36 is 52, so that's possible. So let's do the other ones of these, please. Okay, and what's the tilt? 4 and 6 for that one, and it's not possible for that one. Okay, any other questions, let me know, and I'll get back to you. Thanks, Juno.